Okay, classwork correction. This is question 9 from page 304. Okay, so you should have completed this on Monday, but page 304, and this is question 9. I gave you the coordinates for A, B, C, and D, and what you need to do for this is part 1 is to find the coordinates of the midpoint between A and C. A being the point minus 4, 4, and B being the point 2, 4. Sorry, AC, 2, minus 4. Okay, like you would have seen in class, the first thing you should do with this is write out the formula for midpoint. It is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It is so important that you label your points so you do not get confused with what numbers you need to choose. This is the first coordinate, so that's why it's x1, y1. This is the second coordinate, that is why it's x2, y2. With that in mind, we're now going to use the numbers or the formula to put in numbers. x1 is minus 4, plus x2 is 2, all over 2. y1 is 4, plus y2 is minus 4, divided by 2. Minus 4 plus 2 is minus 2, divided by 2. And finally, 4 plus minus 4, that's 4 minus 4, is nothing, over 2. So the answer to that is 2 into minus 2 goes minus 1, 2 into nothing goes 0 times, so the coordinate is minus 1, 0. That's part 1. Part 2 of the question is asking you to investigate if BD has the same midpoint. So B is the point 2, 4, D is the point minus 4, minus 4. Again, you should label your points x1, y1, x2, y2, and write down your formula x1 plus x2 over 2, y1 plus y2 over 2. Off we go. So x1 is 2 plus x2 is minus 4, all over 2. y1 is 4 plus minus 4 over 2. 2 plus minus 4, that's 2 minus 4 is minus 2 over 2. 4 plus minus 4, that's 4 minus 4 is nothing over 2. It's the same. You can see it as what we had earlier on. Apologies. 2 into minus 2 is minus 1, and 2 into nothing is 0. So we're asked to investigate if the two coordinates are the same, and you'll say yes, BD has the same midpoint as AC. Okay, now that completes the correction of your classwork. We are now going to do some new learning, and the new learning is on page 305 of your textbook. Okay, we're now going to be talking about slopes. So we've got the middle of a line. We're now going to be getting slopes of a line. Consider AB and EF. AB is this line. EF is this line. You can see it's kind of a slope or an incline. AB is steeper than EF. Steeper means it goes up faster. Okay, the angle goes up a little bit faster, and it's a greater of a challenge for the skateboarder. Although both maps have the same height, the horizontal lengths are different. Okay, so the distance from here to here and the distance from here to here are different. Although both, to measure how steep a line or its line segment is, we use a mathematical slope. The slope is calculated by putting the vertical height, this is the vertical height going up, which is called the rise, how much it's rising up, over the horizontal length, which is the run. Now, what I'd like you to do in your book now is highlight this. So to measure how steep a line is, we use the idea of a mathematical slope. It is the vertical height over the horizontal height, but your formula is the rise over the run. Okay? We're going to see this in a number of different questions. So I'm going to take the skateboarder in purple. It's rising up 4. It's actually not, it looks a little bit higher. No, it says rise 4 meters and run 2 meters. With that in mind, you're going to put 4 over 2. Likewise with this one, it's rising up 4 meters, but it's running out 6 meters. That's 4 over 6, which can be calculated down. So 4 over 2, 2 goes into 4 2 times, so the slope is 2. 4 over 6 divides down to 2 over 3, and it can't be simplified any further. 2 is a bigger number than 2/3. That means the slope is greater, or the intensity of that slope is bigger. With that in mind, this brings us into the formula for slope. The letter for slope is m. That's really important. You're going to see that quite a bit. The formula for it is rise over run. But there's a second formula here that we'll deal with on Friday. We're not going to deal with it today. But the second formula is y2 minus y1 over x2 minus x1. And you might remember me referring you to the log tables on page 18. But you can see slope. The letter is m, and the formula y2 minus y1 over x2 minus x1 is there. Okay, so yes, there is a second formula for slope, but at the minute, I'm just going to introduce you to the letter m and rise over run. That's what we're going to deal with today. So, let's move on. I'm going to do one example for you, and it's example 1 on your page. We're then going to move on and talk about positive and negative slopes, and I'm going to give you today's questions. I'm going to redraw out example 1, and you need to do the same in your copy. So, the title for this is slopes. Slopes of lines. What I would like you to draw, and you're going to get your pencil for this, is we're going to measure out 8 boxes. So 1, 2, 3, 4, 5, 6, 7, 8. On the right hand side, we're going to measure up 3 boxes. And we're going to join the 2 points to create a kind of a triangular shape. Okay. So this is example 1. So you're asked to find the slope of the given ramp. So we've been given a ramp here, which is that red line. And I'm just going to write in the equation or the question. You're asked to find the slope of the given ramp. When each box or each unit is 1 meter. Okay. So 1 box is a unit. So that means that's 1 meter. So although it's 3, that's 3 meters. And although that's 8 boxes, if each unit is a meter, that means that's 8 meters. Now, if I want to calculate the slope formula, which is m, is the rise over the run. The rise, it's rising up 3 units, and it's running out a total of 8. So the slope of this is 3 over 8. It's not going to get any smaller, as in it's not going to, you can't divide it down evenly anymore, so you leave it as 3/8. So when it comes to getting slopes of lines, You will see it in question 3 in particular. You need to create a triangle. See the red line? Create a triangle with that shape, and then you will do the rise over the run. You will do that for each of those when it comes to it. So when you're given a question where you do not have coordinates, like we had up here, like these coordinates, you have to use the boxes or the units to help you. And that's when you use this formula, rise over run. There's one other important thing. Back to the book on page 306. Negative slopes. When you read diagrams, especially the Cartesian plane, you read the diagram from left to right. Okay, that's really important. So we observe a line from left to right. If it's going up, so from left to right, that's going up, it's positive. If from left to right it's going down, it's negative. So rising lines have positive slopes and falling lines have negative slopes. So you have to read it from left to right. So if it's going up, it's positive. If it's going down, it's negative. Today in class, we're going to look at a series of questions. So at this stage, you should have taken down in your copy the corrections from yesterday's homework. You should have taken down in your copy the example of slopes of lines. You might also take down reading slopes. You need to read from left to right. If it's going up, it's positive. If it's going down, it's negative. Okay, so there are 2 important notes with slopes. You'll be following on questions now. Your classwork for today is that you go to page 307. In it, we're going to do a series of questions. We will concentrate on questions 1, 2, 3, and 4. Okay, so your classwork today is questions 1 to 4, really, 1, 2, 3, and 4. You can start them now, but join me live.